Let me tell you a little bit about Pliops. Our mission is to massively accelerate performance and lower the infrastructure cost for cloud-based data-intensive applications, including databases, analytics, AI, ML. We are really lucky, and really the core of our company is around the expertise that we have, and they are some of the best in the world. We have experts in databases, flash storage, semiconductor, and the background of the companies include many different ones, but to highlight a few is Samsung, Intel, Amazon, Microsoft, and Yahoo, where Edward came from before this mission. We are engaged with over 20 Fortune 500 cloud and enterprise companies. They're either deploying our product or they're testing with it, and we're making great progress there. Lots of accolade from industry recognition wise. The last one was we're the top 10 cool tech company. That was as recently as February. And some of our strategic investors include SoftBank, Intel Capital, NVIDIA, Western Digital, and Xilinx. A little bit about the product. The flow we'll just explain right away what the product is and what it does, and then we'll move into some of the issues that the cloud operators that we're deploying our products at are seeing and how we're solving those problems. So the product itself, our solution consists of a half-height, half-length PCIe card that very easily integrates in any server. At the core of it, it's the Pliops Storage Processor combines multiple key data and storage technologies into one device that together multiplies their benefits. We implemented a hardware-based storage engine using breakthrough data structures and algorithms to deliver hundreds of Xeon Gold cores equivalent performance. And this is what it would have taken to do all of this on the host. And as a result, we are eliminating the inefficiencies of software-based solutions. As far as the pillars of the product benefits, reliability, we'll show you lots of data around this, but we can deliver what we call drive fail protection, which is the rough equivalent of RAID 5 with the ability to survive multiple drive failures at 2 times the performance of RAID 0, which is incredible. So no trade-offs to delivering that high reliability performance. You can scale anywhere from 2 times to 15 times the performance. Again, depending on what application you pick, you'll see that. And again, different customers are relying on different one of these pillars, and sometimes they combine it. So with all else being equal, the capacity can be 6 times more than what software-based solutions can offer. And then really the last one is the efficiency and using the ability to use the lowest cost TLC and QLC SSDs for any workload. So this takes away the cloud operators and the infrastructure guys' pain of being able to pick which workload goes where, what container goes to what infrastructure, how do I orchestrate all of this. If the infrastructure is inexpensive, that can meet any performance and cost SLA, then that makes it a lot easier for the operators to use infrastructure that is built with Pliops. A little bit more detail on exactly how this integrates in the system. So very seamlessly, that's the answer. The card plugs into any PCIe slot in any server, and we use standard components from the OS, NVMe driver, block driver, network block driver. All of that is what comes in standard distributions from the OSs, and we require no changes to any application. We require no changes to any any Linux host drivers. All of that is seamless. And we work with any SSD that is sitting adjacent to us, any type of SSD. And like we talked about before, we make all of that deployment easy for the user. And those SSDs are still available for a side process or maintenance opportunities to go be checked that on an individual basis, be replaced, etc. All of that, we're not taking any of that away. And we give the user the ability to use any kind of an SSD they want. Now let's talk about infrastructure a little bit. And I want to tell you a little bit about how the infrastructure was, or at some places still is, and how people are changing that. So if you look at what we call yesterday's picture, it was very compute-centric. It was around CPU based servers, that did everything. They did traffic control, they ran the applications, they ran the storage management, and they weren't as overwhelmed because there wasn't as much, they weren't inundated with the data that was coming over the network. The storage mix was not just flash, it was a combination of rotational media and SSDs. And so these traditional server CPU-based architectures have hit their limit for data-intensive applications. And overcoming inefficiencies for scaling performance and capacity leads to excessive server sprawl, increasing OpEx and CapEx. So what are people doing? As I mentioned, there's even more data that the cloud guys are dealing with. Many more devices on 5G network, many more devices on the edge. And you saw the trend and how the AI ML applications were the first ones that essentially left the CPU. They're running in their own domain on a GPU system. And storage is following suit. So in this case, the Pliops Storage Processor is relieving the stressed CPU to take over the storage tasks and offload it to a hardware model. And this will allow the CPU to run better and for the storage to be higher performance, provide higher capacity, higher reliability, and endurance. What does this mean when it comes to cloud deployment? For us, we are seeing two major deployment models. One is around disaggregation or disaggregating infrastructure, and one is around empowering the application server. With the disaggregating infrastructure, it's not that different than how people used to do things or still are doing things in the traditional IT and the enterprise IT, and that is, I have my island of compute, I have my island of storage. Traditionally, this has been hard to do in the cloud because cost triumphs everything. The building blocks need to be the same. The way you build, you started the way back when hyperscalers started building things, that's how things started. So they're not going to introduce anything massively expensive into their structure. They're using essentially the same component to create different islands of functionality, one being compute, one being storage. And in this case, we are being loaded or being used in the storage servers. Another example that we'll go over is when, the nice thing about this is that they can achieve pretty much everything that a super expensive AFA will do, but they're building it out of commodity servers. They're building it out of open source software. And all of this translates to being able to operate things simpler, more efficient, so that orchestration is easier, so that moving containers is easier. The other model is a lot of people are still combining storage and compute in one really powerful server. And that's what we call empowering the application servers. And in that case, they're building reliable database servers with all flash and their goal is, when putting Pliops in, is to be able to host more instances and improve their transaction cost, because they can get a lot more out of the unit of database storage or analytics server and the database server with Pliops.
Tony, I have a question about the disaggregated infrastructure model. So are you implying that the compute server and the storage server talk via NVMe over Fabric, and you are on the storage side of things? I mean, on this at the end of you are the target at the end. So you are not in the compute server, but actually in the JBOFF plus your card, for example.
That's one of the examples. As a matter of fact, I will go over some of that. I will show you an example of how a big public company is doing this. So we'll deep dive in this model a little bit more, and I believe we'll answer your question in that. So let's actually deep dive on this. Let's talk about what the cloud storage, what the cloud operators' goals are for disaggregated storage systems. Well, they like isolation, security, scale, and cost. They don't want to keep throwing money at the problem. Adding servers and SSDs and larger data center footprints is not the answer. They don't want to have, there's no economic data protection for SSDs other than expensive RAID. The storage inefficiencies to accelerate performance. Those are all examples. But isolation is really isolation for all of these. Being able to isolate the storage operator from the compute operator. Security, being able to isolate where the data sits, where the data is being served to the customer, to the cloud customer. So if, for example, a bug shows up or a virus shows up in one end, you have completely avoided that. This is very critical nowadays. You've seen in the news how systems are getting hijacked, and one area that the operators are working is to make sure that this isolation is helping them in the security space. Scale. You can scale storage and compute differently because they have different needs. Again, this all goes back to how people did it in the enterprise world, but this is at a massive scale and cost becomes important. So with cost in mind, they are building this with commodity servers, with less expensive SSDs, all flash, and with open source software. So we are working with actually 3 public cloud providers. These are really large entities, and this answers perhaps some of the questions you have, Enrico. So what they're doing is they're creating sort of a cluster of servers for storage, and their compute servers are sitting somewhere else. The way they talk, and again, this is from different operators, is different. You can have NFS connection, you can have CIFS, you can have Fuse, OpenStack Swift. All of these are typically the protocols that you're hitting this storage. We have seen, for the most part, a flavor of Lustre that our people are using for the server cluster, but this doesn't. We don't want to say that Ceph is not in this category either. So what are people doing? When they add Pliops in the mix, remember in that top model, there's enough. They're using a distributed file system. There's enough capability in there that if a server goes down, then they can recover. But so availability data is always there. It's always on. But still, majority of those server failures are due to drive failures. And depending on how much capacity you put on those servers, there's still rebuild associated with that. So rebuild is still a problem for them. What they're doing with Pliops is that now they're creating multiples of SSD groups instead of a single one, and they're striping it across those servers. And what Pliops is doing for them is that for each one of those SSD groups, they're getting dry fail protection per node. They're using QLC SSDs without a performance hit. So I've met my serviceability SLA, I've met my performance SLA, and I'm not incurring new cost because I can put massively bigger drives in that system. And what that translates to for these customers, in this model, they were able to expand the capacity by 45% per node with zero downtime, and were able to reduce the cost by 77%. What they told us is that the cloud operators and the people that are using their services are saying this is more reliable, easier for the orchestration software. I takes the guessing out of what container goes where, because the overall storage capability is becoming less flavored, fewer instances of storage that are capable to handle any load.
So Tony, is this, in that situation, is that stripe across multiple servers, is that the JBOFF solution, or is that just a Pliops sitting in each one of those servers? There are 3 Pliops and multiple drives, and you're being able, using capabilities of Pliops to stripe all that data across all those servers?
Pliops is striping across the groups of SSDs, and depending on how many SSDs, and I got to be careful what I tell you here, but there's lots of SSDs in here, very, very dense drives. So they're choosing to put multiple cards. So Pliops is protecting the data across each multiple SSD group.
So this could be this would be a JBOFF, a very dense JBOFF, possibly with a CPU sitting there as well. Is that?
It can, but in this case, this is a very, very big 2U server that can house, let's say,
hundreds SSDs or something like that.
Yeah.
So at what level of density does the investment in your hardware accelerator start to pay off versus just adding generic compute?
Well, the density today, let's say per node, is around 8 drives with about 8 terabytes each, and we are able to go to 24 drives at 16 terabytes each with us, and still meet everything else. And by the way, save money. So,
a question about the QLC SSDs. So, to get around the performance hit with QLCs is by striping over different SSDs. Is that correct?
It's a good question, because really it goes back to what we do fundamentally in our product, and that is we make the data smaller. We create these variable size objects, and then we create these long string of data, which is a very complex thing to do, to write to flash. At that point, so by just doing that, we'll make the QLC behave beautifully. But on top of that, we can stripe the data at that point without any read modified write penalties. So it comes an operation that is serially, and we're using a very advanced distributed algorithm to do this, and it's designed around flash. So QLC already will benefit just because we are doing the work. We are doing the work for essentially conditioning the data before it's placed on QLC, and being able to stripe it with our advanced algorithm comes for free. It's an afterthought. So,
okay. Do you also cache the data before you write it, or do you just leave it up to the integrated cache of the SSDs then?
We have a staging area on our card where we use to run our database to essentially our advanced architecture to be able to stage the data. So there is some cache on our card.
Thanks.
I want to hand it over to
Tony. Isn't that the card a single point of failure?
The card is not a single point of failure just because you can, what we do is we use what we call NVDRAM to keep the data that is relevant to us alive. And that data is backed up to another SSD flash. So at any time, you can recover from any kind of a failure and lose no data.
Yeah, but I think we're talking about the availability versus the ability to restore in the event of failure. This sits in the I/O stream, right? So if the card were to somehow fail, then your access to the media behind that accelerator card would be taken away, correct?
Interesting point, because we still have an agent on the host that can read the data directly from the SSD. So as long as SSDs are alive, we have no trouble with that. And then, by the way, our card is rated at 4.5 million MTBF. It's rated higher than Xeon. So the question is, will a Xeon chip fail before us? So.
Sure. And what about the write activity in the event of a card failure?
In that case, we go to like a RAID 0 model, and so we pre-warn the operator, and essentially we get out of the way of the data.
So Tony, again, in the failure mode of operation, the data is striped, so your recovery solution must have knowledge of that. It's compacted. So I mean, all that the things that you're doing to try to improve the endurance of QLC, for instance, has to be undone in order to be able to access the data and that sort of stuff. Is that correct? I mean, is that what you're doing there? And that solution runs in bare Linux, VMware, Windows, or where, I guess.
Well, majority of the cloud customers that we're talking to are running bare metal and they're running Linux. So our software agent essentially is another smart driver on the host that can directly read the data from SSDs.
And the write operations would still take place outside of, would use the agent or wouldn't use the agent? Because I mean, the data is sitting there compacted and striped and all that stuff. And as you start to write, it has to be maintained into that format, right? And all that stuff.
We do go to a short period of data unavailability until, well, it's not unavailable, meaning you can read from it, but the writes need to be going to an alternative card, correct?
Oh, so you could actually have an alternative card manage the same set of SSDs. I mean, is that?
That's something that we're planning. Again, we've been through thousands of hours of validation with these guys particular, and that's an option for them, and they have not deployed it.
Okay, thanks.
So we talked a lot about how the hyperscalers might use this solution. You mentioned disaggregated models. Are you just to help us get a frame of reference? Are you partnered with any of those other solutions? Like, what would this actually look like if being consumed in enterprise?
So with enterprise, again, it's more of it. You're right. It's a partner approach, except when it's something like a fully open source system. So let's take MariaDB or MySQL, for example. We are creating no additional operations or maintenance need, in this case, for the end user. We're just another block device. So think of it as another SSD sitting in the system. And we stand behind our warranty and we service our card. But really the application or the software that is the storage software underneath of it will have no dependency on any additional maintenance. In the case of, let's say, something like Redis, we are working with a a few distributors out there to make it even more tightly coupled